The purpose of this demonstration is to show what it means to be an influential observation with respect to the correlation coefficient as well as the least squares line. And what we're going to do is we're first going to plot several points kind of grouped together in a relatively linear fashion. And I'll go ahead and plot the least squares line here. Now, what I'm going to do is I'm going to plot a point up here. Now we see the correlation is about 0.9525. When I plot a point up here, that correlation dropped tremendously to 0.58. And this is the effect that outliers have on this correlation. This result right here would be considered influential in terms of the correlation coefficient because its y value is so much larger than all of the other y values, and the x value is kind of in the middle of these guys here. So this particular outlier is considered influential for the correlation, but notice that the regression line did not change dramatically. And this is because there's enough points down here, 21 points down here, to kind of offset the effect of this one outlier that it has on the line. It can't offset the effect on correlation, but it didn't really change the behavior of the line itself. So if we go ahead and remove that. The second kind of situation would pose a data value here. Now, a data value here is considered an outlier. It definitely is far away from the rest of the data, but it had very little effect on the correlation, and it had very little effect on the least squares line. So while this data value is an outlier, it is not considered influential in either of those respects. Now when you put a data value down here, we have what would we consider to be an influential observation with respect to the correlation as well as with respect to the least squares line. This particular data value brought the correlation down from 0.95 to 0.46 about, and it also dramatically changed the appearance of the least squares line. So data values that typically have outliers in the x direction typically affect both the shape of the model as well as the correlation coefficient, as demonstrated here, where outliers that are far from the pattern but still kind of lie on that model there, they have very little effect. They'd be considered outliers, but they are not influential to the least squares line or to the correlation coefficient. And data values up here would be considered influential with respect to the correlation, but not influential with respect to the least squares line. And this is the different kinds of behavior that can be exhibited with scatter plots when you are looking for these influential observations.